question about the homework.
Yes, anything. I'm ready.
I have h
Of x.
x.
Age of
Yes.
x.
I'm sorry. Yes, I'm sorry.
Yes, we
Age
need to
of
get
x.
we need to get used to it. That's fine. It's new. Okay.
Equals 4x squared minus 4.
Good.
So my question about that was I solved it, but
You have to tell me the problem first, and then you'll tell me what you did. What are we asked to do? Without knowing what we're asked to do, I don't know how to answer.
yes. So that's the one that we fill in the x. So h of x, it's h of 5b. So it's
so we are asked to find the age of 5b?
Yes, sorry.
Okay, so remember what we just said. Age of something is 4 times something squared minus 4. So first we have to identify what the function is telling us. And the function is saying f, or age of whatever, is 4 times whatever squared minus 4. So now blindly, I don't have to do anything, just plug it in. So 4, 5b squared minus 4. Because this is 5b, this is 5b. Now we will try to simplify it. And first I have to square this quantity. So what do we get when we square 5b?
25b.
No, 25.
Minus 4.
25.
B squared.
Yes, I cannot pick and choose. Perfect. So it's 5 squared, b squared. Awesome. 4 times 25 is 100. B squared minus 4. No one can touch this anymore. We completely simplified it. These are not like terms. We cannot proceed any further. Is that okay?
Yes, I didn't understand why the answer was 100b squared because we had.
You have to multiply these. Oh yeah, the b squared. Yes, I got it.
Because if I used it in 25, I thought it was gone, but then I see that we have to put the b squared.
Of course.
That's why.
Yes.
Okay, I understand now. Thank you.
Thank you. Very good question. Anyone else? Other questions? Anything else you worked on? Anything else you need help with?
Oh, I have one more.
Please.
So there was a problem about the f of x, and then it had.
You said f of x?
Yes.
Okay.
Equals. I don't know what's that symbol. The one that has the.
The bars?
No, the other one. The one that has this. I forget the name of it.
Is it parentheses?
Braces. No, braces. That's it. Thank you.
This is braces, and this is brackets.
Yes. No, braces.
Okay.
So it's as f of x.
It's a piecewise defined function.
Yeah. So it's that 6x plus 2.
The first one is what?
6x plus 2.
Perfect. If
x is less than 0.
Good.
And then 2x plus 1. If x is less than or equal to 0. So that then
it's not possible. It's not possible. If this one is less than 0, this one cannot be less than or equal to 0. It will not be a function.
That's what I saw.
So you mean greater than or equal to 0. It's not possible. It will not be a function.
That's what is showing in my screen.
Absolutely never, ever, ever. So you can share your screen. So let's take a look. Remember, you read it less than or equal to. I wrote it greater than or equal to. But you read it less than or equal to.
Let me see.
Not possible. Not possible. It's hard for me to see, however. Let me check. Yeah, so it's less than 0 and greater than or equal to 0, of course. You see the first one is less than 0 and the second one is greater than or equal to 0.
Okay, sorry, then I was.
That's okay. So let me copy. You want f of -3. You want f of 0. You want f of 5.
No, the D, f of -100 plus f of 100.
Okay. Perfect. You can stop sharing now. Excellent. Thank you so much. Good. So, so this is not required. In order to determine this sum, I have to plug in -100 in here and 100 in here. Because -100 is here and positive 100 is here. So, -600 plus 2, and then plus 200 plus 1. So when I plug in -100, I get -600 plus 2. When I plug in 100, I get 200 plus 1. So -600 plus 200, that is -400, and plus 3, which is negative, what is it, 397. Is this okay? Is this okay? Other questions? Lali, is this okay?
Understand. Yes, thank you.
Perfect. Anyone else? Other questions? Anyone? Okay, in that case, and if you find anything else, you can always stop me, as you know, anytime. Okay, so now let's move on to graphing. That's our next step. Graphing this piecewise defined function. And I'm going to pick one, and if you need, we need more, you can pick. 63 on page 254. So we are given f of x. We say f of x piecewise defined function. There is no need to say braces. So it's a piecewise defined function. It's x plus 3 for x less than -2. And it's x minus 3 for x greater than or equal to -2. So here we're asked to graph. We're asked to graph this function. Please remember, every time we're asked to graph a function, we have to start with a domain. This is our first step, domain. Number 2, table of ordered pairs. Number 3, graph. And potentially, if we are asked to, number 4, range. These are absolutely mandatory steps. Unless the function is extremely simple, y equals x, and then we know how to graph it, and so on and so forth. But all the other cases, when I'm asked to graph a function, I have to go through these steps. I have to find the domain. I have to present the domain in the table of ordered pairs, where I put any ordered pair that I will use to graph the function. Then I present the graph, and then I write the range. This is the correct order, and this is what needs to be presented. Okay. So first of all, I'm going to copy the function here because I don't have room over there. So f of x, again, is a piecewise defined function. X plus 3 only when x is less than -2. And x minus 3 only when x is greater than or equal to -2. Since we studied interval notation, can anyone give us the interval notation for these two? If I don't hear anyone, I have to pick. Hunter, will you help us with x less than -2? How do I write the interval notation?
We bracket -2.
There is no bracket.
Maybe.
There is no bracket. It's less than.
Oh, I see. Parentheses
Yes.
-2 to infinity. Infinity. Period.
Let's read it. X less than -2.
I see. Negative infinite.
Brilliant. Yes. Thank you.
To
Excellent.
-2.
Good. Who can help with this one, please? Bailey, would you like to try this one?
No, thank you.
Bracket.
Yes. Awesome. Yes.
0 -2.
Let's read it.
Brackets.
Let's read it.
Okay.
X greater than or equal to -2.
-2.
Oh, infinity. Oh, sorry.
Infinity and the parentheses.
Excellent. Good. Now we are able to establish the domain. Can anyone looking at these identify the domain of this function? So again, this piece is only for, or this interval is only for this piece. This interval is only for this piece. We are asked to find the domain of this function.
Would it be negative infinity, infinity?
Of course, brilliant. Thank you so much. Nothing is missing. Everything to the left of -2, -2, and everything to the right of -2. So the domain of this function is all real numbers. Perfect. Knowing that, I can start my table. I have to write the domain in the table. My next step, notice that this value of x is crucial for this function. Why? Because at -2, this function changes shape from this to this. So -2 has to be in the table. 0 is in the middle. The domain is all real numbers. I have to have 0. Now, -2 is somewhere here. Now, the next step. So, one more time. I put in 0. I'm at step 2 with a table. I put the domain. I put 0 because it's in the middle, because the domain is all real numbers. If 0 is not in the domain, I will not put it in, but 0 is in the domain. It's all real numbers. Then I put in the most important element other than 0, let's say, which is -2. Something major happens there. Next step.
I have a question.
Yes?
I'm sorry if it sounds like a dumb question, but
It's
when
not.
you say you have to put a 0.
Yes, 0 is always in the table if the domain is all real numbers.
Okay, it's just to identify the table of where 0.
I have to present the x and y intercepts no matter what, if they exist. So 0 is an element that has to be in the table, unless the domain does not include 0. So if the domain were 1 to infinity, there is no way I can put 0 in there, because I would have 1 to infinity and 0 is to the left.
Got it.
But 0 is a crucial element in the real number set. Good. Next, please follow. Under -2, see these two symbols. You gave them to me. They are correct. So these two symbols have to be right under -2, and they are touching exactly under -2. So not something like this. No, exactly under -2. I have those two symbols. This one opening to the left and this one opening to the right. You will see in a moment why. The next step with the table, I will do this. Just to make sure, you can say this is an overkill. I will have to agree if you say that. For the interval -infinity, -2, I have to use this function. So I'm just going to write on top of it on the table. Obviously, from -2 to infinity, I have to write this function, because that's the function I'm going to be using for that interval. Now, I'm always looking for the x and y intercepts. Notice that when x is -3, -3 to the left of -2, and I'm sorry I put that -infinity so big. I need more room. So -3 is a very good point for x plus 3. So when it gets dry, I'm going to write -3 there. -3 plus 3 is 0. Again, I picked -3 and not -4 or -10 because -3 plus 3 is 0, and I'm always looking for the x and y intercepts if they exist. Then I'm going to do something that you would disagree with, and rightfully so. I'm just going to let it dry for a second. So when I want to plug in -2 here, and you should be appalled. You should say, no, you're not allowed to, because -2 is here. -2 is not here. That's correct if you say that. However, I would plug in -2, I will get +1, and I will write it inside a parenthesis, and I will say open point. Stick with me, please. And stay with me so you'll see what happens next. Now on the other side, I have -2. I'm allowed to plug in -2. -2 minus 3 is -5, and I write it inside the bracket. And I make myself a note, full point. I will plug in 0, I get -3. And of course, I will also plug in 3 because I know 3 minus 3 is 0. So this was -3 here. All I needed 2 points here because it's a line. I needed 2 points here. I got 3, more than enough. Now, so I completed the table of ordered pairs. Now I want to graph and then determine the range. So what is very important here is to understand that if you graph something like this will be totally incorrect because this is not a function by the vertical line test. So these two pieces are completely separate. They cannot be extended, so they overlap each other. Okay, so how do I graph? So here it is. -3, 0. -2, 1. Open point. Done. You don't have to use colors, but I'm using colors just to make a point. Now, -2, -5. So I'm going to use this. 1, 2, 3, 4, 5. This is a full point. 0, -3. This is a full point. 3, 0 is a full point. And it's done. This is the graph of the piecewise defined function we see here. If you extend the orange or extend the purple, This is not going to be by the vertical line test, is not going to be a function. This one stops here at -2. The other one starts at -2 to the right. So again, this is the orange, and this is the purple. I think I used this one, I don't remember. As you see, they do not overlap by the vertical line test. This is a function. Now, can anyone give us the range of this function?
It is 0.
The range is obtained by looking at the values of y and crossing the graph with horizontal lines and watching for possible gaps. Can anyone try? Bree, would you like to try? Ayana, would you like to try? It's okay if you're wrong.
Is it -3?
Okay, so let's go back to the previous lesson. Just remember that only working in Pearson, those problems in as a homework is not enough to build your confidence. So when we determine the range on this function, we cut it with horizontal lines. And the range for it was from -infinity to this point. I don't remember what that point was because I didn't write it down. When we determined the range of this function, we didn't say 5 or 3. We said everything from -infinity, not 0, and everything to +infinity. So, again, I'm begging you. I don't mind begging. I perfected the art of begging. I'm kindly asking you to review the notes. That's why I'm sending them to you. So again, can anyone give us the range of this function? Please.
What is that?
Yes, Rand, go ahead.
That bracket -3 of infinity.
Don't forget this arrow. Okay. I guess my fault.
Infinity to infinity.
Yes. -infinity to infinity. You always look at the arrows. The arrows tell you what to expect, right? So if it stops here, it stops here. If this one stops here, it's a different story. But there are arrows in there. Okay, good. Any questions on, thank you. So any questions on piecewise defined functions, graphing piecewise defined functions? Are we comfortable with this?